Hi and welcome back to the channel. In this tutorial we will be looking at the derivatives of trig functions. The derivatives of trig functions are for the most part easily remembered and applied. However, I would like to go through the steps of how we exactly get them. This is called differentiation from first principles. You should know the three primary trig functions of sin x, cos x and tan x. To find the derivatives of these trig functions, firstly let us introduce the definition that is displayed at the top left of the screen, which is f dash of x is the limiting value of delta x equals f x plus delta x minus fx divided by delta x. Here I have introduced a new notation for derivatives. Instead of dy dx, here we have f dash of x. But let this not confuse you, it means exactly the same. Also take your attention to the compound angle formula sin A plus B. This is important as we will need this to derive our derivatives. So, letting sin x equal f of x, f of x equals sin x. Substituting this into the formula, we get f dash of x equals sin x plus delta x minus sin of x all over delta x. Now using the double angle formulae for the first term in f dash of x, we get sin of x plus delta x. The a and b has just been replaced by x and delta x equals sin of x cos of delta x plus cos of x sin delta x. Then substituting this back into f dash of x, we get f dash of x equals sin x cos delta x plus cos of x sin delta x minus the sin x, and this is all over delta x. So let's rearrange this formula and factor it out. So f dash of x equals sin of x cos delta x, and now I'm going to put the minus sin x term here, minus sin x plus cos x sin delta x, and this is all over delta x. So factoring this would be f dash of x equals sin x cos delta x minus 1 plus cos of x sin delta x, and this is all over delta x. So I want to take your attention to something that we call small angle approximations, where sine theta approximately equals theta, cos theta approximately equals 1 minus theta squared over 2, and tan theta also approximately equals theta, where theta is measured in radians. So in our case, the theta will be delta x. So let me just write that down. Theta equals delta x. So substituting this into our equation for f dash of x, we get f dash of x equals sine of x brackets. Now cos delta x is 1 minus delta x squared over 2, so we have 1 minus delta x squared over 2 minus 1 plus cos x, and the sine delta x from the small angle approximations is just delta x. And that is all over delta x. Now we can simplify this slightly. So f dash of x equals sine of x. The ones in the brackets cancel, so we're left with minus delta x squared plus cos x delta x, and this is all over delta x. Rewriting this out, we get f dash of x equals minus delta x squared over 2 sine x plus cos x delta x. Delta x. Now there's a delta x in each term, so we can cancel some of these. So that cancels with that, and the squared term cancels, so we're left with f dash of x equals minus delta over 2 sine x plus cos x. So finally, I bring your attention back to the equation for the differential of sine x, and we see here that delta x tends to 0, which means that the number gets smaller and smaller and smaller and approaches 0. So thus we can take delta x as 0. So with that being the case, it would just be 0 times sine x, where we could cancel this out. And finally, f dash of x equals cos x. So the derivative of f of x equals sine x is cos x.